Hey YouTube, in this video I'm going to cover radians. I'm going to show you where they come from and apply it to some exam questions. If you want my free resources on this topic, then click the link down below. Hit the like button and consider subscribing. I hope you enjoy the video. Radians, like I was saying before, so a radian is a new way of measuring an angle. A degree is known as a planar angle that is defined that a full rotation is 360 degrees. However, the idea that a circle has 360 degrees is incorrect, technically, and is just something that was fixed a long time ago. The same way, like, who decided 1 kilogram is 1 kilogram? Who decided that 1 centimeter is this big? You know, these things are all planar angles. They're all like measured and have been fixed a long time ago, but there's no real basis to these measurements. Now, the most likely explanation is that in the ancient times, with the use of sundials, and through observations of the constellations making a full rotation every day, it was easy for old mathematicians to equate 365 days to approximately 360 degrees in a full rotation. Imagine a full rotation of a circle being 365.242199. You know, 360 does the job well enough. Even better than 370 because 360 has more factors, right? So, since degrees have a unit of measurement, it is not useful for us when performing important calculations involving calculus. When we do calculus like differentiation, integration, you know, like you've done already in year 12, we don't like things with units because then you have to do all kinds of conversions. Now here comes radians. Radians are a unitless measurement which also measures angles. How does it work though? It's still to do with circles, and the key definition is a radian measures the ratio between the arc length of a circle and its radius. Yeah, so it measures. Quite importantly, remember, like I said, you lot, if you go on to EduFlow, there is a workbook which I would like you lot to print out. They take me quite a long time to make. If you print them out, a lot of this stuff's already written, so you don't have to write it. You just write alongside me. So what I want you to write is underneath or in your notepad. It doesn't matter. A radian, in simpler terms, measures how many times bigger the arc length is to its radius. Yeah, so it measures how many times bigger the arc length is compared to its radius. So I just had a nice simple question. If we have 1 radian just means, if you read my statement above, it means that the arc length is 1 times bigger than its radius. Well, if you're 1 times bigger, it must mean that they're the same. Yeah. So 1 radian means that the arc length equals the radius. So if this is your arc length, and this is your radius, if they are the same, this angle at the middle, we would just write 1. That's all. Yeah, we would just say 1. Nice and simple. So radian tells you how many times bigger the arc length is to its radius. If the radius and arc length are the same, that must mean that the angle is 1. Yeah. So what is the angle in a semi and full circle in radians then? Well, we know that in a semicircle with general radius r, then we know that a full circle is 2 pi r. Yeah, the circumference of a circle is 2 pi r. So in a semicircle, it will be pi r. So this length here is pi r. Well, then we ask ourselves, how many times bigger is pi r compared to r? Well, we know if you times r by pi, then you get pi r. So that must mean that the angle here is pi in radians. Yeah, so r times pi gives you pi r. Yeah, nice and simple. But we know in a semicircle, usually the angle is 180 degrees, right? So that must mean that pi radians, this is the conversion now, pi radians is equal to 180 degrees. Yeah, so pi radians is 180 degrees. And we could do this in a full circle. I mean, we could double both sides and say 360 degrees is 2 pi radians. Or in a full circle, we still have the radius r. And we know that the full circumference of a circle is 2 pi r. Yeah, all the way around. Okay, so the full circumference is 2 pi r. Again, you're asking yourself, what do you need to times the radius by to give the circumference? The answer is 2 pi. So the angle at the center in radians is 2 pi. So that must mean then that 2 pi radians is 360 degrees. It's actually quite simple. It's just something that you lot have to get used to. In year 13, we use radians a lot. From Thursday, we're going to be doing a lot of solving equations with radians. So trust me when I say you lot are going to know radians inside out. I do a lot of questions in radians just so that you lot get used to it, because it is really important that you do get used to it. Yeah. Now, what can we say then is the conversion between radians and degrees? Well, essentially, we just need to know what the conversion is for 1 radian. Do you know when you do currency conversion, you always need to, if you want to know what pounds is in euros, you always need to know that 1 pound is, I think right now it's €1.18. So you always need to know what the value of one of something is, and then you know the conversion. So if I said, what's the value of 10 pounds? You just times it by 1.18, right? Now, if I want to know what the conversion is from radians to degrees, all I need to know is what 1 radian is. Okay, well, what do you have to do to both sides to get 1 radian? You just need to divide both sides by pi. So if you divide both sides by pi, you'll get 1 radian is 180 over pi degrees. Yeah, very simple. So that means to go from radians all the way to degrees, all you do is you divide by pi and then times by 180. Or you could do it the other way around. You could say times by 180, times by 180, and then you divide by pi. And that will take you to degrees. We're going to do some conversions as well, just so that you can see how we do it. It's very rare for us to have to convert between degrees and radians, but here we can do it. But to go from degrees to radians, you just do the opposite. So you times by pi, and then you divide by 180. It really is quite simple, yeah? In fact, we can actually work out what 1 radian is in degrees just by this conversion. Don't forget, you lot should have seen this. Remember my calculator? Yeah, this is sick. I love this. So I'm doing 180 divided by pi. Yeah, okay, sweet. So it's about 57.295, etc. So 57 point, so we can say 1 radian. If you want to write this down, this is fine. 1 radian is 57.29 ... You can even say it's about 60 degrees. So it gives you a bit of context, right? So like if you see an answer of like 2 radians, you know it's about 120 degrees or so. Yeah, so it's nice to know what 1 radian is, so you can kind of go from there. But really and truly this year, we're going to be using radians so much. Yeah, we love radians just because it's unitless. Towards Christmas, when we're doing calculus, the hardcore integration, you know, everything's going to be in radians. You're all going to become experts at this, I promise. Yeah. All right, so just some conversions, yeah, just so you can see in action. It's super easy. If I want to convert 60 degrees into radians, remember what we do. We divide by 180 and times by pi. So we divide by 180 times by pi, or you just times it by pi over 180. Yeah, times by pi over 180. Now I'm going to do this one. Well, actually, we could do it on the calculator. So what we got? We got 60 times. Hopefully you got these calculators with you, and then you're writing alongside me. So pi over 3. Yeah, pi over 3. Part B, 270. To convert that into radians, remember I wrote this here. You're timesing by pi and dividing by 180. Yeah. So times by pi over 180. You lot are going to get used to it. It's 3 pi over 2. Yeah, nice angle there. 173. Now, this one's just a completely random angle. I just wrote a random angle down. If you do type this in the calculator, if I go back and change that, 60 degrees, 173. You just get 173 over 180. Now, if that happens, please, unless they ask, do not convert that into decimals. Obviously, you can do this, yeah, 3.0194, da, da, da. Don't do it. Keep it as a fraction. Usually they'll say, look, keep your answer in terms of pi. So here we are going to keep our answer in terms of pi. And there's your answer, and that's okay. Next one, convert these angles to degrees. So we're just going to do the opposite. So pi over 4, remember if we go back, to go from radians to degrees, we times by 180, divide by pi. Or we times by 180 over pi. It's just the other way around, yeah? Now, pi over 4 is a very common angle again. That's 45 degrees, but let's write it down anyway. So we got pi over 4 and 180 over pi. 45 degrees, like I said. So this is an angle which is going to be very, very common for us, yeah? In fact, I'm going to list them out for you, but also, like I said, you lot, please download and print off the workbooks that I put on the platform. Yeah, they're always there. They're always unlocked. It's just the ones coming up, they're not there yet because I haven't made them. But make sure you do that ready for the lesson. It helps you, you don't have to write any of the questions down. You literally just follow along, yeah? Next one, 7 pi over 10. Now, this one is not a common angle, 7 pi over 10. So times by 180 over pi. This kind of thing, they don't ask in the exam as well. What I'm doing is making sure that we know how to convert if we ever needed to. You never know. I have an example today where you can see where you do need to make a conversion first. So 126 degrees for that one. And then finally, part C, doing 0.65 radians. We're going to times by 180 over pi. So we've got 0.65. Now, can you see this huge decimal? Because 0.65 is two significant figures, our answer, we should really keep it to two significant figures. So let's just say 37 to 2SF. We want to keep it consistent, yeah? 2SF. Now, just so you're aware, sometimes, instead of writing 0.65 radians, examiners might put a C up here. Now that C just indicates that they are talking about radians. That C does not mean a unit, yeah? It just means that they're talking about radians, that's all. So they either will write down that it's radians, or they'll put a C to indicate the angle is in radians, that's all, yeah? It's not like where you put degree and that's a planar angle that does require conversions if necessary. So just so you're aware, yeah, you might see it in some places. All right. Common angles that you must be familiar with because we are going to use them so much. Yeah, let me turn off this calculator. We'll use it later. So the ones we've already shown are 180 over pi. We've got 360 is 2 pi. We've also just proved that 270 is 3 pi over 2. Really, everything is a multiple now. So if you half that, 90 degrees is pi over 2. If you half 90, you get 45 degrees, which is pi over 4. We proved that one already. We did 60 degrees is pi over 3. And if you half that, you get 30 degrees, which is pi over 6. These are the most common ones. I want to make sure that you guys know these. Yeah, we can't be slacking when it comes to these. If I ask you, guys, what's 45 degrees? You should immediately know it's pi over 4. Yeah. Another one, which, we don't really use, is 120 degrees, which would obviously be 2 pi over 3 if you double the 60 degrees. That one I'm not too bothered about if you don't remember. We don't really use it that much. But these ones, super important. We need to know how to sketch sine, cos, and tan in radians. So we should all know what the graphs look like. So sine graph goes up, down, up. As you can see, my drawing has become much better from the summer gains program that I was doing, because I'm using this tablet, right? I don't know if you guys can see it. Look at this. It's pretty cool, right? But you know, it does take some getting used to, because I had this old rubbish one before, and it was just not great. This one has a bit of friction to it, which is nice. It literally feels a bit like you're writing on paper, which is cool. But it meant, I don't know if you guys remember me drawing circles. They were awful, man. They're all right now. Okay, so the sine graph, you know, 1 minus 1, that doesn't change. You know, that's just the y-axis. But the x-axis does change, because whether we're talking about radians or degrees, it does make a difference. Now, we know the peak of the sine graph usually is 90 degrees, right? Now, 90 degrees is pi over 2. Yeah, so on the workbook, all these axes are there, so you're just drawing over the workbook, yeah? Then, sine graph crosses the x-axis at 180 degrees, which is pi radians. The next trough here is at 270 degrees, which we know is 3 pi over 2 now. And then the sine graph comes back at 360, which is 2 pi. We're going to do some sketching as well for these. I'm going to show you some cool techniques to sketch graphs, because students always hate sketching and translating graphs. So I'm going to show you an easy way to do it. Next one is the cosine graph. The cosine graph obviously starts at 1, comes down, and then goes back up. 1, minus 1. The cosine graph crosses the x-axis at 90, which is pi over 2. 180 at the trough, which is at pi. And then it crosses the x-axis again at 270, which is 3 pi over 2. And then 360 is 2 pi. Yeah? I'm going to be reading out the conversions a lot as well, so that it gets into your heads. Yeah? Because I'm going to do loads of this. The conversions are going to become second nature to you. I'm just going to keep repeating. Yeah? Now the tan graph, it starts from 0, 0, flicks up, asymptote, full wave, asymptote, and then half a wave, like that, yeah? Right, the tan graph obviously starts at 0. Now, there is an asymptote at 90 degrees. The asymptote 90 degrees is pi over 2. Crosses the x-axis again at 180 degrees, which is pi radians. Asymptote, the asymptote is at 270 degrees, which is 3 pi over 2. And then finally, 2 pi is where it gets to 360 again. So all the graphs that you already know, you need to know to convert the x values to radians as well. Yeah, but they'll become second nature. Yeah. These kind of questions students hate, yeah? They don't like sketching graphs, but I'm going to show you a nice, easy way to sketch graphs. It's really quick. So y equals cos of 1/4 x. Now the basic idea here is f of 1/4 x. So if you remember from year 12, if I gave you something like f of 1/4 x, when it comes to, so we call whatever's inside the bracket, we call that the input, right? We call that the input. Yeah, exactly. So we stretch it, it's a stretch. So anything to do with the input does the opposite of what you think. So even though it says 1/4, you're actually multiplying it by 4. Now I'm going to show you an easy trick for this. You don't want to draw the whole cosine graph and stretch the whole thing by 4, right? And then think, oh, which is the part I want within the range between 0 and 2 pi? What I'm going to show you is to sketch the cosine graph that you are then going to stretch outwards to 2 pi. And the way we do it is we modify the range. Can you see the range here is x? I want the range to be 1/4 x. So all I need to do is divide everything by 4. So you get 0, divide that by 4, will be 1/4 x. 2 pi divided by 4 is 1/2 pi. Yeah, 2 divided by 4 is 1/2. So the modified range, we just divide everything by 4. Now all you do, remember what I said? I said we want to draw the cosine graph, the only part of the cosine graph that we will stretch out to the range being between 0 and 2 pi, yeah? So all you do is you draw the cos graph within this range. So I've actually done it. Look, here's the cos graph there. All I'm drawing is the cos graph between 0 and pi over 2. It starts from 1 or 0, 1 here, and it comes down here to pi over 2. That's the cosine graph within the modified range. This is the mod range cosine graph. Now remember what you lot said. You said if it's 1/4 x, all you do is you stretch the graph by a scale factor of 4. Now look what happens. If I take pi over 2 and I times that by 4, it goes back to 2 pi, and that's my answer. So all I'm doing is I'm stretching this, yeah, from 1 still, from 1. But remember, quarter x times all the x value by 4. So pi over 2 times 4 takes me to 2 pi. And that's your answer. Here's your graph. This graph here is y equals cos of 1/4 x. It's the cosine graph stretched by a scale factor of 4 in the x-axis. So you can see, by doing this method of modifying the range, you do not need to sketch the whole cosine graph and then stretch the whole thing and it becomes a mess. We only want to sketch the part of the graph that is within the modified range, and then we do the transformation from there. So in terms of the tan graph here, sketch tan of x minus pi over 4. Step 1, modify the range. So modify the range. I need to subtract pi over 4 from all of these values here. 0 minus pi over 4 is minus pi over 4. X minus pi over 4. Then we're doing 2 pi minus pi over 4. You guys have your calculators on you, hopefully. That just is 7 pi over 4. Guys, hopefully you remember, pi over 4 is 45 degrees. Yeah, 45 degrees. Now that's useful, and I'll show you why, but obviously 45 degrees is between 0 and 90 degrees, so it's exactly halfway between the tan graph where it's 0 and the asymptote. So what we need to do is we need to draw the tan graph between minus pi over 4 and 7 pi over 4. So remember before, there was a flick, asymptote at pi over 2, one full flick, asymptote, and then one flick there. That took you to 2 pi. This is 3 pi over 2. This is pi, 0. Now you can see I haven't done enough. Remember, we wanted minus pi over 4, right? So it's going to go back, like that, and another asymptote. Now because of the reflection, this is going to be minus pi over 2, right? Now remember what I said? I said minus pi over 4, that's like minus 45 degrees, right? That's going to be right in the middle here, between 0 and minus pi over 2, because 0 is just 0, but minus pi over 2 is minus 90 degrees, right? So minus pi over 4 is here. So it means I'm looking at the tan graph from this spot here. Yeah? Now it might be useful for you lot to type in what tan of minus pi over 4 is. Tan of minus pi over 4 is going to tell us what the value is here on the y-axis. Now if you do type it in, it should tell you minus 1. Yeah, so tan of minus pi over 4 is minus 1. Next thing is, where is 7 pi over 4? So Jivan, 7 pi over 4 came from, remember the end bit of the range was 2 pi? Yeah, the end bit of the range was 2 pi. But I need to minus pi over 4 from that value so that I can get the modified range. So if you do that in the calculator, where's my calculator? We're doing 2 pi minus pi over 4. Like that, yeah? So all I did was, in the range, I just minus pi over 4 from every value, yeah? Does that make sense? I've sketched the tan graph. Is it working? There you go. Yeah. So I've identified the tan graph at minus pi over 4. Now I need to identify the part of the graph which is at 7 pi over 4. Now 7 pi over 4 is right in the middle between 3 pi over 2 and 2 pi. Because you can actually work out, so look at the calculator. If you want to do the conversion, remember what it is. You times by 180 and you divide by pi. If you times this by 180, you can kind of just remove the pi. 315 degrees. 315 degrees is right in the middle between 270 and 360. So 7 pi over 4 is in the middle there. And by symmetry, it's going to be in the same place as minus pi over 4, right? So 7 pi over 4. So it's over here. Let me get rid of this calculator. Okay. Now, what we need to do is identify the tan graph between those two values. So it starts at minus pi over 4. It goes up. Then there's a full wave here. And then it comes from the bottom and then stops here. Yeah? Now, what I've highlighted, that's the tan graph. Yeah? What I've highlighted is the tan graph between the modified range. Yeah? So what I've highlighted is the tan graph between the modified range. Because now this is where this becomes really easy, which is why you lot need to practice. It's in my homework. In fact, it's question 1. Is tan of x minus pi over 4, you remember from year 12 and even GCSE, x minus pi over 4 takes the graph and it shifts it to the right by pi over 4. Now look at the highlighted bit. If I shift that to the right by pi over 4, then where it starts at minus pi over 4 is going to end up at 0, which is where they wanted us to start from in the first place. And where it's 7 pi over 4 is going to shift to the right, and it's going to end at 2 pi, which is the end point. Yeah? So all I did is I sketched the relevant part of the tan graph, which I just need to shift to the right now. And you can see I did not have to draw loads and loads and loads of the tan graph and shift everything. I only needed to draw the relevant bits within the modified range, which I can now shift. Yeah, and that's my answer. The highlighted bit is literally my answer. All I need to do is add pi over 4 to the x values. That's it. Yeah, so redrawing it, I'm literally just drawing the highlight. Yeah. So you can see the highlight starts at minus 1 here. So it starts at minus 1 here. And then it comes up. Yeah, you can see I've literally just copied that. Then I have an asymptote. Then I have one full wave. Then I have an asymptote. Can you see how I'm lining things up so it looks cleaner? Then I have, it comes from the bottom, but can you see it stops at minus 1? So it comes and it stops like this. And that ends at 2 pi, and it now begins at 0. You see how clean that is? It's clean because I only needed to draw the relevant part of the tan graph, and then all I needed to do was copy and paste it as my answer, because the yellow highlighted bit is what I shifted to the right by pi over 4, and that's it. That's my solution between 0 and 2 pi. Yeah? Now, all I need to do is shift everything else. So here at 0, if I add pi over 4, it's going to be at pi over 4 here. Pi over 2, where the asymptote is, remember I shifted it to the right by pi over 4. Pi over 2 plus pi over 4, you don't even have to say the pi's, it's a half plus a quarter. That's 3/4 pi. Pi here, that's just 1. 1 plus a quarter is 5/4, or 5 pi over 4. 3 pi over 2. 3 over 2 plus a quarter, 3 over 2 is the same as 6 over 4. 6 over 4 plus a quarter is 7 pi over 4. Yeah, that's your answer. So you can see I did not need to draw too much. That's really important. If you're in the exam, you should not have to draw loads and loads and loads of one graph, shift everything, and then redraw everything. It just becomes really horrible. So when sketching graphs, you follow these steps. you modify the range. Yeah, only if it's to do with the x values, you modify the range. You draw the original graph and identify the original graph within the modified range, and then you just copy and paste it because that's your answer. And that's it. It becomes really simple. Yeah. Right, guys, I hope you learned something new today and you enjoyed the video. If you did, feel free again to subscribe and like the video. Share it with your friends if you feel like it will benefit them as well. And as I said, if you do want a free cheat sheet to this topic, then make sure you ping me on WhatsApp and feel free to follow me on Instagram as well. All the details are in the description below, and I look forward to seeing you in my next video. Peace.